Good day, everyone. In our today's class, we are going to look at velocity time graph calculation. Remember, in our previous class, we've lay our hands on a question under velocity time graph, but we are looking at another question today, which is more complex than the previous one. Now, this question, this is the velocity time graph diagram given in the question. Now, let me quickly summarize what this graph is all about. It is a journey of a particular person. That is, let's say the person take off from a point here, then landed at this point. The whole time taken is approximately to be 500 seconds. And the highest velocity attained is noted in the diagram to be 600 meter per second. Now, if you look at this diagram very well, you will realize that we have a point A, which is given down here. I've extract this diagram. I extract this diagram from this image given to us. Now, we have this portion to be A. We have this portion to be B. Remember, this is a right angle triangle. And if you look at this one, is a trapezium. This is a trapezium. If you change it like this, you are going to have something of this nature. Now you have this again, which is C. That's a rectangle, and we have triangle, which is what? D. I've named each of the image to be A, B, then C, then the last one is what? D. Now remember, in calculating the total distance travel in a velocity time graph, we are to calculate or sum the total area of the image that is given to us. Now, if you look at this, each of what we have in this graph, we can extract the image out, and that is what I have done so far. You can see it here. Now, in this graph, we have 4 different images being extracted out, though we can extract more than that. How? I can decide to split this one to 2. We have a rectangle out, then another triangle, meaning we can have it to be triangle, rectangle, triangle, rectangle, then what? Triangle. In that regard, we can have the image extracted to be what? To be 5. But let's have it to be what? To be 4. Now, what the question asks us to calculate is calculate the total distance travel. The total distance travel is what we are calculating in the question. And since we have extracted out each of the likely image, that is the image from, we have extracted the image from the what? From the velocity time graph given. Let's now calculate for the total distance traveled. In as much as we know that the total area of each of the image found in the what? In the graph will be the total distance traveled. Let's calculate now. The first one is what? Right angle triangle. Remember, the area of a right angle triangle, this A, the area will be half A. The A is 100 here. Then the H is what? Is 300. How do I get this A from this graph? Look at this graph very well. The object take off from this point and move with an acceleration to attain this velocity of 300. At what time? At 100. That is, this place is 0/0. That is, the origin is from what? Is 0. That is, between this place and this place, we are having it to be what? 100. And the time taken from here to here is what? 200. That is addition plus this 100, making it to be what? 200. Meaning, from here to here is 200. Then from here to here is what? 100. From here to here is 300. Then if you minus from here to here from that, you have this place to be what? 100. Now, back to this. How we get this 100 is just the distance between this place to this place is what? 100. That is the time. The difference in time from what is 0 to 100 is what? Is 100. That is 0 minus what? 100 is what? 100. Now, the highest speed attained by this object at this stage is what? 200. Remember, this is the triangle. The height of the triangle is this. Can you see? And year to year, who serve as the what? A is what? 100. Now, this place is now, the area of this right angle triangle will now be A is equal to half H A. Half AH rather. Now, we can easily calculate the area of this one now. We have this to be half. What's the value of this A? Is what? 100. Derived from the what? From the graph. And that's what? 100 times. What's the height? The height is calculated to be what? 300. Seen in the image extracted. Now we have this to be what? 300. Then we are going to have this to be this divided by this. We are going to have what? 50. Now we are going to have 50 times 300, and this is going to give us 15,000 in what? In meter square. We've calculated for this. Now we are left with what? This. Remember, this is a trapezium. How do we get all the figure placed on this? All the figure, the value placed on this image. Remember that between this and this, from year to year is what? 100. Then from year to year is 200. That means you are removing 100 from this 200. Then you have this place to be what? 100. Now, if you look at this image, if you turn it like this, you are going to have something of this nature. You can see that this is this. This is the dotted line. Then year that is 100 is placed here. Then the highest image from year to year now, we have it to be 300, and that was why I placed 300 here. From year to year, we have it to be 600, and that was why I placed 600 here. Now, what we are going to do now, if you look at this, this is a trapezium. Now, if you look at this image, the image is an image of what? Trapezium. Now, to calculate the area, you are calculating for the area of trapezium, and that's half brackets A plus B into what? H. How do you do that? You have your A to be what? 300. You have your B to be 600. And you have your H to be what? Here is your H. Here is your B. Here is your what? A. And that's what? 100. Now, if you calculate this now, this will cancel this. You are going to have what? 50. If you add this together, you are going to have 900. That is 900 times what? 50. You are going to have 45,000 in what? In meter square. Now, the next one now, we are calculating now is rectangle. This C. This is for A. A. This is for B. This area of B. Image B. This area of image C. Image B rather. Now, the second one, the third one is rectangle. The rectangle, area of a rectangle is what? Length times what? Times breadth. Now that is B times what? L, or B times H. That's going to give us, let's use BH. Here is our B and these are what? H. If you look at this very well, this dotted line is this and this dotted line is this. If you look at this very well, this dotted line represents 600, and that's why I place 600 there. If this place is 600, the same height they have. So this place is 600, this place will also be 600. Since this place is 600, this is also 600. And if you look at this, to know this from this to this, the distance between this and this, you have your 200 here. You have your 300. Just minus this from this, and you have it to do what? The same 100. And that was why I placed 100 here. I just change the image like this. Now I have this. This is going to give us, what's our A? Our B rather. Our B is 600 times 100. 100. And that's going to give us, this is C, area of C. And that's going to give us 600,000. 6 in meter square. Now the last one is this. Now D. To calculate the area of D, let's come back to this place. The area of D is going to be area of D. That's going to give us the same thing. Is a right angle triangle. Is going to give us half AH. The same thing we did here. Half AH. What's our A here? Our A is 200. How do we get that 200? Remember that this place is what? This is the object. The object retarded from this point to this point. That is, the object come to rest at this point. Now, when as at this point, the time taken for that object from here to here is 300. Now, between this place and this place, we are going to have, if this one is 500, from here to here is 300, and if this is 500, then you are minusing this from this, you are going to get what? 200, and that was why I placed 200 here. Now look at this place, this dotted line that you have here is traced to the maximum velocity, which is what? 600. That means you are going to have your A to be, your A is 200 now, is 200, and your A is 200, half 200 times, what's your height? That's what? 600. If you divide this by 200 divided by 2, we are going to have 100, and this is going to give you the area of D is going to give you 100 times 600, and that's going to give you 60,000 in what? In meter square. Now we've calculated for the area of each of the image that we extracted from the word, from the velocity time graph given to us. How are we going to calculate for what we are asked to calculate, which was initially what we are asked to calculate is the total distance traveled by the object. Now, I've explained earlier before when we started the class, I said the total areas of all the images that are found in the velocity time graph will represent the total area of all the images found in the velocity time graph will represent the total distance traveled by this object, by the object in this motion. Now we've gotten the value of the first image, the area, to be 15,000. Now what we are going to do now is just to sum everything together. To sum everything together, we are going to have let me let please let